Hey, okay, so now here's the whole point on this. We're using a table, we're building the table. We're using the table to try to answer these questions down here. Okay, so obviously, I mean, look, here's the thing. They wouldn't even be asking this if this thing existed at 3, but we'll go ahead and do it. Now, I went ahead and put it into the calculator, all right? And you'll have one that you'll do on your own on this later on. So what you do is I'm going to table setup. This time, start. It doesn't matter where it starts because I'm going to have it ask. All right, so I'm going to have it ask. All right, so here we go. So we're going to the table. All right, here's 3. It's of course undefined. It's undefined. That is a. I'll type this time. Undefined. Okay, and you can see that because 3 squared is 9, right? 9 plus 6 is 15. 15 minus 15 is 0. That's bad enough. But on top, you also have a 0 on top. So that's indeterminate form. We got a 0 over 0, but for right now, we'll say undefined. Okay, let's try 2.9. Just going to go through this pretty quick. Oh, no. A fraction? I don't want a fraction. Let's see here. There we are, decimal. Yeah, I don't want fraction. Fraction's hard to tell anything about. So let's go back. There you are. Okay, so at 2.9, we've got 0.1266. If you ever, if you need a little bit more, sometimes you can go around top of that. Ooh, look at there. It did round to the 4th decimal place, and that's probably okay for our work. Okay, so we'll go ahead and go with that. 0.1266. Four decimal places is pretty good. Okay, 2.99. All right, so let's go here. Boom, boom. 2.99. 2. All right, and if I arrow over that, I can get a better feel. But again, I'm pretty happy with that. 0.1252. That's fine. All right, so 0.1252. Okay, that'll work just fine for us. Move you over a little bit. All right, let's go another one. So over here, let's go down. 2.999. Okay. I don't believe it's exactly that. Nah, but rounded to 4 decimal places it is. All right, so I might carry it a little bit further this time. 0.12502. Right? Okay. And now let's check. Let's check on the other side. All right. So on the other side, 3.001. 3.001. Well, I believe it's the same value. Let's go up here and look. Let's hover over that. No, it's lower, but it got rounded up. Okay, so I'm gonna do that. 0.12498. Right. Ugh. All right, there we are. And then 3.01. So okay. 3.01. Blah. All right, and again, just because I want to see a little bit more of it. All right, so 0.12484. 484. I think we're starting to see what's happening here. All right, but let's do one more because it asks us to. All right, so down, 3.1, 3.1. Boom. Let's hover over that bad boy. All right, and then put it right here. I got 0.1, 2, 3, 4, 5, 6. What is going on? 5, 6. Okay. 3, 4, 5, 6, 7, 9. Okay. All right. So anyway, all right. So hey, so from the left, okay, that was this that we did to begin with. Coming from the left, it looks like we're heading to 0.125. Matter of fact, the calculator said that when we typed it in within rounding. All right. So oops. All right. So it looks like we're heading to 0.125. That's what it looked like to me. And then from the right, those are the larger values. It's doing the exact same thing, 0.125. And guess what? Since we have those agreeing with each other, that's what you put as the limit. All right. Now we got a kind of a cool thing here about kind of reminds me of our road to nowhere kind of thing. Um, as you're approaching this point on both sides, but there wasn't anything there. But good thing is they were both heading in the same direction as they were building it. Okay. And that's exactly what this is. All right. So the limit, and we've already done this. If the limit from the left and the limit to the right both agree, and they're calling them big L, then that's it. Then your limit as you approach C in general, no left or right, will also equal that L. Okay. Oh, and I like this. The limit as x approaches C on f of x will exist if and only if the limit as x approaches C from the left is equal to the limit as x approaches C from the right. Perfect. Pretty simple example, but I like that we have the limit existence theorem formally now.